Hey, hello, and welcome to the show. It is me, JP, and I have a totally new mixer. So hopefully I'll remember that it has a mute button on this channel, and that won't cause more audio havoc. But I am here for you with JP's product pick of the week, and I've got a very cool new product pick, and I think a fun little demo that I'm excited to show you. And I first of all want to say hello to the people in the chat. We've got over in our YouTube chat, Beatagraf Abdelhagen and Dave Odessa and Carl McIntosh. Hello, thanks for joining. And then over in our Discord chat, that's the place to check out if you're wondering where most of the chatters are. That is at adafruit.it/Discord, and you can head on over to our Discord server and then look for this live broadcast chat channel right here. And hello to C. Grover and Thin Man and Paul Cutler, Blitz City DIY. Thanks for stopping by. And I am soliciting feedback on my audio setup. So if you hear any issues with it, let me know. I was hearing a weird hum with it earlier when I was trying to monitor it over my big old headphones, and I think it was just the headphone wire crossing paths with the mic, I hope. So let me know if you hear any weirdnesses there as we explore the wild new world of a brand new audio mixer with built-in compressor. So what have we got going on here today? Well, if you want to get a jump start, head on over to that QR code or that URL. You will see the product pick of the week. And it is, we had 100 of them stashed before the show. Those have been released into wild circulation, and there were another 80 or so, I think, before that. So we have a bunch of these in stock. They are, excuse me, at a deep, deep discount. And you can watch this show from inside the product page. So fear not, you won't miss anything. Head on in to that page. Get ready, because you don't need a coupon code. We've just got the discounted price on there. I've teased it enough. Before I say any more, let's have Lady Ada tell us about this week's product pick. Take it away, Lady Ada.
The OPT 4048, which is, like you said, is the product of the week, which is why the code is XYZ color. So this is a XYZ color sensor. What that means is that it doesn't give you RGB data output. It's like, usually you get like 0 through 255, red, green, and blue. This one actually gives you CIE color, X and Y, which can be converted into color temperature. It also gives you lux output. And it's like a well-calibrated sensor specifically for light temperature reading, which is why it doesn't have like a light on. Like usually color sensors have a reflective light on it that will let you reflect light off of the thing you're sensing. But that's not what these sensors are used for.
I've never seen that word, Tristumulus.
Tristumulus.
That's a cool word.
Tristumulus?
Yeah.
Yeah. Isn't there like a book about that? Like
it sounds like a planet.
The Tristumulus
well, it sounds like a planet where everything is made out of threes.
Yeah.
Okay. All right.
And very unstable. Okay, so I can show this on the overhead. I got just a quick demo that I just threw together real fast.
Tristumulus.
It's Tristumulus. So this is just an ESP32 with it. And you can see, so it's, I'm kind of moving it around, but it can measure the color temperature of the ambient light here, which is 2800, 2900 degrees K. That's about right because we have like fairly warm indoor lighting because we're in a house. And then, what I can do is I can mess with the light since I've got my my phone.
Yeah.
And then when I do this, the lux goes up to 2000. The color temperature gets a little cooler. It gets like 3000, 3100.
Oh, so there was an observation in one of the chats, but I just want to confirm.
Yeah.
Can you test like the LED lighting? Like, could you be able to test LED stuff?
Yeah, like if you're like, is this a warm, cool, and what temperature is the LED? It's not going to tell you like, I mean, you can use the X and Y to find like what color emission it is, but like the thing it's really good for and what it's really designed for is color temperature of like lighting. So, I think it's actually used, I think a lot of the times, this is, used for sensors, of course, but it's used for televisions and monitors where they want to change, the ambient light will be detected and then they might change the lighting of your device to make it look better under different lighting. Because, it's like colors look different.
When it's dark, you want the dark to look different, yeah.
You want things to look different under different lighting conditions and different color temperature conditions. So it's a scientific sensor, but it does the problem, solves the problem very well, and it's very inexpensive to use. And we also made a little web app that you can use with this, and we'll show a video after.
I like this. You can do so many things because you get the data and then like make music out of it. So many things you do.
Okay.
All right.
Yeah, that's right. This, let me bring up a photo too. This right here, this is the product pick of the week this week. It is the OPT 4048 XYZ Tristumulus Color Sensor Breakout. This is essentially a warm to neutral to cool white light sensor. So these are used in things like nice modern television sets that can adjust the white balance of the content you're watching to match the room so that it doesn't stand out from your environmental lighting conditions. This is used for things like laptops and phones. In fact, I was looking at the product sheet, which I'll bring up in a second, but I made some notes from there. Let's see, or did I? No, we'll look at that. Okay, so it'll measure light intensity as well as color temperature. So how bright things are in lux. It measures the X and Y coordinates on the CIE, which is the International Consortium, I think, or Commission on Illumination, which is in French, CIE. There's a particular color space, which I'll show you a graph of, which maps the full color spectrum in X and Y space. And so this will return those X and Y coordinates on the CIE graph, but it'll also give you a color temperature in Kelvin. So what we're used to, if you've bought lights in household lighting or done industrial lighting or theater lighting or film and video lighting, you'll usually see color temperature expressed in a very, very warm light at about 2500 degrees Kelvin up through a very, very cool blue light at about 6500 degrees Kelvin. So we can get that returned, which is really useful if you're trying to match lighting, and that's what I'll show you in my demo here in a second. Let me bring up the product page. That's not it. Let's go, there we go. There's the product page, so you can see right now it is a discount price from $9.95 down to $4.98. You can get a maximum of 10 per customer. And if you scroll through here towards the middle of the page, you'll see we have a link to the main Learn Guide. Let me go back to the top of that by Tim C. So there's the sensor. And you can see on here we've got a jumper on the front there for the LED. So there's a little green power LED you can turn on and off by either cutting or resoldering that. By default, that's on, but in case you had a very enclosed space and you didn't want any green light reflection bouncing off of a glass lid, or you just don't want to see that the thing is on, you can cut that. If you take a look at the back there, we also have an address jumper. So this runs over I2C, and you can use 2 of these on an I2C bus, either with the default address of 44, or cut that little jumper, and I think, I actually don't know what address that goes to. I'm going to guess 45, but I don't know. And then we've got I2C data, clock, power, ground in the STEMMA QT ports on the sides there. That's how I've got mine hooked up that I'll show you in a second. Or you can use the pins on the bottom there, which give you VIN, ground, clock, data. There's also an interrupt pin, and you can use that address pin to set that high or low to change the address if you don't want to do it with the little solder jumper there. Here's a little closer look at those. This will tell us, yeah, 45 is the address you'll get if you cut that little jumper. And then we've got code for testing this out, getting it set up, using this with CircuitPython and Python libraries, and a little example code here that'll plot that out into your serial plotter, which is, or your just a REPL. There's also an Arduino example, and this will show you how to hook that up, get that up and running, and again, a little simple serial output. And then there's also this web serial demo. If you check this page out, this will allow you to see the plot of that XY on the CIE chromosticity diagram, which is what that color space is that I was talking about. This is just another web page I found just searching for info on the CIE color space. So we'll find plotting of X and Y on this will give us this range of cool white to warm white that's in that bright section there. So let's get to, let me check for any questions first, but otherwise let's get to some demos of this. Just a comment from Zoe Sherry on YouTube. Seems like a fun way to create false indoor windows, like combining stained glass, mirrors, curtains, LEDs. You could simulate additional windows that aren't there. Absolutely, yeah, that's a cool trick. Someone mentioned putting on the other side of blackout curtains to read the outdoor lighting, the match indoor light to outdoor color. Absolutely, yeah. So this is definitely used for those sorts of, you know, match the outdoor to the indoor, match your TV or device to the environmental lighting that you're in. So, oh, and yeah, before I go further, let's, if we go back to the Learn Guide and head to the Downloads page. If you didn't know this, we usually have a Downloads page that has a link, among other things, to the data sheet. And so this is a chip from Texas Instruments. Let me zoom in on this a little bit. So you'll see here in the Applications section, I like to check this out. What do they think this is used for? Why did they build this? Display brightness and color adjustments. So again, dimming, besides the color correction, but also dimming. Camera image color correction. Auto white balancing, building automation and control, lighting control systems, and tablet and notebook computers. So those are some of the ideas of what they've created the chip for. So let me go to a little demo here. So here you can see I've got my OPT 4048 hooked up to a Feather using a Stemma QT cable. So it's running over I2C with the default settings. And I'm going to show you my REPL here. So I'm running this fairly simple CircuitPython program. I made some adjustments for a demo that I was working on, but this in effect is what you'll get if you use the default example code from the Learn Guide, is the CIE X and Y coordinates, as well as the lux or brightness and the color temperature, which the chip provides. So you don't actually have to synthesize the X and Y positions to come up with this. It's actually reported by the chip. And you can see it's varying just small amounts, but if I move my hand in front of this light, you can see I've got a video spotlight right here. And so as I put my hand in front of that, you'll see the lux value change. So we're at about 100 lux hitting the sensor, and now we're up to about 700. So this lamp is a bicolor video lamp, which means it's designed to go from warm light to cool light through passing through neutral light. And I've got a control on here for brightness, and I've got a control on here for color temperature. So right now, if I turn this off, you're going to see that the color temperature stays at about 3100. The reason is the main light that I have right over the top of my monitor is at 3100. It's a warmish light. So I matched that on this light, which I can dial in 3100. And so that's one of the uses for this, right? I've checked the color temperature and then I've matched it. I don't have to do it by eye. I can do it fairly precisely on this light, which makes things like color balancing and color correction later easier if you're doing any post-production. So now what I'll do is I'm going to adjust the brightness on the lamp here. So you can see as that goes up, things get a lot brighter. And my lux reading is going up to about 12,000 or so lux. And then I can dial that back down. But you'll see the color temperature remains pretty consistent here. This is a well-designed light. It doesn't change the color as you change the brightness, not very much. Sometimes I'll see some little fluctuations there. I think as it's going through a big reading change, you'll see the color temperature fluctuate on the readout. But I'm not doing any averaging of samples. These are just like every 10th of a second I've got a sample. So I'll put that at a moderate brightness, and now I'll change the color temperature. So I'll go all the way to the left, and you'll see This light now is at 2500 Kelvin, which is super, super warm. You can see very, very, very warm light. Since there's other light in the room that's a little cooler than that, this is not measuring all the way. But if I try to cup my hand over here and hide some of the other light, so it's just the spot, and I crank that up, we should get closer to 2500. And then let me bring that back. As I adjust that cooler, you'll see it starts to go to a pretty neutral, up in the 4000 Kelvin range. And then we'll get real blue with this, which on this is set to 6500. But again, with the other light in the room, it's not going to get that cool. I will try, let me just turn off this light right here for a moment. Yeah, I think I'm still reflecting off of warm objects as well. If I take this and bring it right up to my light, now you can see I'm up at about 5300 Kelvin, so pretty close, getting closer to the 6000. So that is, I think, a decent practical example of using this sort of thing. And now the output that I've got here is just simply reading and displaying the values. But what you could do is drive other lights with it. So if, for example, I hooked up some neopixels to this feather that's sitting here, I can read what's going on in the room, and then I can match the neopixel color, especially if I'm using like white neopixels, where there's a warm, a neutral, and a cool white diode in there. We can match that pretty precisely by reading these values and then doing a conversion from Kelvin into the RGB, or the 3 different white diodes on that type of warm, neutral, cool neopixel strip. So this is what the key thing in the code. Let me scroll up here. You can see I'm importing the OPT 4048 and grabbing OPT 4048, conversion time, mode, and range. And then I set that up on I2C, create the color sensor object, set the range to auto, and we might be able to get more precise results if we clamp that into a specific range. Conversion time is how many internal how much time it has to take the measurements internally before it reports, and I have it reporting that continuously with this mode continuous. And then in the main part of the code here, I'm just extracting from this color sensor.CIE. So I'm saying, give me the CIE X and Y and lux values, and I'm casting those to these variables, X, Y, and lux. And then I'm printing all of those out. So I've got up to 6 decimal places of X and Y, and then the lux value. Let me just turn off this little squiggly diagnostics line. And then by saying color sensor.calculate color temperature based on X and Y, those X and Y values that it got, it does the math internally to the chip, so I don't have to have any of that in my own code. And then actually every 0.2 seconds I'm reporting that. And that is it. That's all you need to do to be able to grab that data and then use it for whatever you like. So let's see. Let me see if we have any questions here in our chats. Over in YouTube. Yeah, Zoe Sherry says, could I use this to make a NeoPixel strip match whatever my TV is doing nearby? So this one is really designed for the white, warm to neutral to cool white. You would want a different color sensor if you're trying to match RGB. And so usually for environmental TV lighting stuff where there's NeoPixels behind the TV that are adding some color behind the wall, those types of projects, you'll usually want to get colored strips and a color sensor that's designed for that. Let's see. Betagraph said, it's a good sensor, but I tried it at less than 1 lux and it struggled a little. That said, less than 1 lux is a darkened room, so struggled just a little. Yeah, I have not tried that in super dim conditions, so I'm not sure what maybe setting some of the ranges on it would allow it to be a little more sensitive to the type of lux that you're looking to measure. Good. And then over in our Discord, nope, no questions. Okay. Then I think we'll wrap that up there. Let me get this out of the way. I will remind you, if you want to go pick that up, it's $4.98 right now. You can head to that QR code or that URL, 6335, to go pick some up. And maybe pick up some Stemma QT cables so you got extras to plug things into. I can never have enough of those Stemma QT cables. All right, that's going to do it then. That right there is the product pick of the week this week. It is the OPT 4048 Tristumulus XYZ Color and Lux Sensor Breakout. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I'll see you next time. Bye-bye.